Hey, and welcome back. We are now at lesson 2A in the quantitative reasoning course. It does mention that in preview 2A, you analyzed three graphical displays that represented the same data on treadmill ratings. It then asks you to write down what are some characteristics of the dot plot, the histogram, and the box plot, and why do we need different types of graphical displays. As in our previous lesson, this is a good time to hit pause, jot down your thoughts, and then come right back and we'll answer one and keep going. Some possible thoughts to question one are that some displays are easier to read, some are quicker to produce, some retain the original data, and the most frequent data points are going to be easily identified on a dot plot and histogram, and box plots represent quartile information. So it's your opinion, your audience, and what do you need and what are you trying to communicate. Make sure you have your copy of this lesson 2A. Underline some of these objectives. I'll mention some to underline and then you underline what speaks to you. But in this lesson, we're going to notice, understand, look at that same data can be displayed in different kinds of graphs. Different graphical displays have different purposes. Displays can be used to represent one data set or to compare two data sets. After this lesson, we'll be able to analyze a variety of graphical displays and interpret them in context. We'll also be computing the mean of a set of data and constructing a dot plot or a histogram in this lesson. Looking at question 2, it talks about the Consumer Reports article that was described in the previous assignment. Not only did it provide score ratings on treadmills, but it also separated the treadmills into two cost categories, those costing $1,000 or less and those costing more than $1,000. So to clarify, as you should, anytime you see graphs, notice the information being displayed and also notice scale. Are the scales same or different? And we're going to start looking in detail at the items or the dots on the scale. I'm going to read the questions. They're on your in-class page. I'm not going to show them on the screen. I'm going to read them and talk about them using the graphs. Part A, compare and contrast the graphs of these two categories. Again, this is a great time to hit pause. You write down questions or answers to parts A, B, and C, and then come back. Looking at part A, compare and contrast the graphs of the two categories. Great things to look at include minimum numbers, maximum numbers on both graphs. Is this following a normal curve? Does it have skewness, maybe a left tail? Where's the middle? Where are the points bunching up, or where do you see half on one side and half on the other, aboutish? Are you thinking median or mean? Lots of different things that you can talk about. Again, this is opinion, but there are certain words that are good to add in, like maximum, minimum, a middle. Can you see or talk about the mean, median, or mode? Does it exhibit symmetry? Is there skewness? Talk about the spread, the maximum, the minimum. Lots of different things you can say about these graphs, but it appears that the ones over $1,000 bunch up down here on the score ratings, and those less than 1,000 appear to bunch up with higher ratings. What conclusions can you draw? I just mentioned some for part B. You can talk about the frequent ratings. You can talk about, like right here, it appears around 69-ish is the most frequent rating, and over here it appears 73-ish is the most frequent rating. And it does look like the ratings are better for the less expensive treadmills. Part C says, would a histogram or a box plot be a useful method of displaying this data? Your answers are going to vary, and there's not really a greater advantage to using a histogram or a box plot. You can have other opinions. Write down what you think about these graphs. I'm going to still stay on question 2, looking at these graphs, these dot plots, but I'm reading from question 3. Suppose that your friend is going to purchase a treadmill and he or she has plenty of money but a limited amount of time to shop. What would you recommend? Would you recommend he focuses his attention on more expensive models or the less expensive models, and be as specific as you can? I want to remind you that in your in-class student notebook, specifically in my math lab, where it says student materials to print, there are resources, and the very last one is called Writing Principles. You need to look at that because our answers will become more involved in asking for greater descriptions, and the Writing Principles page is great to give you some ideas about what to write, uh, pieces and parts to include, like one of the sample arguments for your friend buying a cheaper treadmill could be, when looking at the bulk of the data points in each of the distributions, the cheaper treadmills seem to have a higher rating, and almost all of the cheaper treadmills are rated, let me see, right here. Almost all of them are rated 70 or higher. That could be an argument for buying the cheaper one. An argument for buying the expensive treadmills is the friend won't want to risk getting the treadmill that scored a 50 because there was one. And since your friend has plenty of money, so he could go ahead and buy the magazine, read the full report, make his decision from there. Either way you want to look at it, you decide, make an argument, should the friend, which treadmill should your friend purchase? Moving on to question 4, it asks us to review the data collected on the first day of class. Since we're an online class, you've been sending your data in, but it's not even due yet. So what I have done is I have taken data from the ones who've already sent in their data recording chart, and I have put their heights, as you see listed right here. Oh, well, let me undo that one. So you see their heights listed here. I've already created a dot plot. I just looked at the lowest number, which was about-ish 5.3, 5.2, and I started around 5.0 and then 5 and 1/10, 5 and 2/10, and I just went on up to 6. Notice the highest one is around 6 and 125 thousandths and stopped up here. Each dot represents a height in our online class of people who have already submitted their information before the due date. I plotted all of those, and question 4a says construct a dot plot of the data of the height of the students in this class. So here is a dot plot. You can replicate this on your paper so that you have practice creating a dot plot. When you have your first test, part of one of the questions will be to create a dot plot with some given information. So you do need practice writing this out in a scale that is fair, that makes sense, that's not skewed or disjointed, and then also practice of writing them and where they are. And then, as you look at Part B, it says compute the mean of the data set. And then we get on to Part C, it's going to say what conclusions can you draw from your calculations. Before we do that, I'd like to discuss our graph. And we do have a dot plot that does have a small rise, and you can talk again about the minimum number we see and the maximum number. You can talk about the spread using those two numbers. You can talk about that we do have a number that occurs most, and that was our 5.5. It occurred twice. You can also talk about where there aren't any numbers. You can also talk about that there are very few numbers. Many things that you could say on Part C and talking about conclusions. And if we were looking for where about is the middle, that's also going to vary based on what you're looking at, where you feel that number would be. And so somewhere-ish, maybe in here, might be a middle-ish number. You might push it a little bit more that way. Make a guess where you think the mean is going to be, and then I want you to calculate. I want you to add all of these numbers, which that is the definition of mean. We're going to add up the total numbers in our data set, and then we'll divide by the number of items that are present. And we have 9 items, so add them up, divide by 9, round maybe to the hundredths or thousandths, and hit pause to do this, and then come back and we'll discuss the mean and finish up this lesson. The screenshot that you see right now includes our dot plot. It includes some words I mentioned earlier in the video about talking, describing what you see in a dot plot. These are some words that are good words to use. I've already mentioned that you start a glossary or flashcards, and these will be some good words to have in your own vocabulary when you go to discuss any of the graphs that we're about to see, but this is specifically for a dot plot. Down here, I did my calculation. I did a sum of all of the data points. I divided by 9, and I got about 5 and 61 hundredths, which 5 and 61 hundredths is going to fall about-ish right here as being our mean of the data. So as you finish question 4C, what conclusions can you draw from your calculations in the graph? Say what you want to say about the students who have sent in their data. We have 3 students who are above the mean. We have 3 students who are much lower than this middle section. We have 3 in the middle. Say what you want to say. Talk about it, discuss it, get comfortable writing some sentences about what you're seeing and describing some details. This concludes our lesson 2A. Look at your calendar and see if there are more for you to complete before this week's deadline.